Hello and aloha. My name is Mike Cuthbert, and I've been a Python user for almost 20 years. But this is my first PyCon, and I just want to say it's been great. Everybody's been so welcoming, and I'm really happy that all of you have come taking time out of your Sundays to listen to the talk. Of course, it's about Python, but it's also about music and about computer science, and mostly about how all these things have come together in my life in an interesting way, or made my life more interesting, and also in the lives of my students. And I hope by the end of this talk, the same for you. For most of those 20 years in Python, until a couple years ago when my wife's career brought us to Hawaii, I was teaching as a professor in the arts and humanities at a school much more known for science and engineering, MIT. And when I was hired there, I had been using computer simulations in my own work in music for quite some time. So it became obvious, it became obvious that because I loved teaching and research equally, I really needed to engage with my students and create courses on how computers could change the arts and humanities, and especially music, my field, especially music's history, theory, and composition. Now, here's the usual way of framing applied computation. You take all our knowledge from CS, from programming, from AI, data science, all together, and you apply it to grow knowledge of some other field, like art, like music, or like the humanities. And this does work. They do grow. And that's an amazing standard paradigm, and I'm glad to talk about it some other year. But what I found was also happening first with the undergraduates in my lab and then in my classes was exactly the opposite, the reverse, that the applications in the arts and humanities were making knowledge flow and thrive in the reverse direction, that arts and humanities were making programming and CS grow. That taking a Python-based music programming class not only opened up new insights about music, but just as often taught and reinforced fundamental computation and CS skills. What emerged for many students, especially students of races and genders underrepresented in computing as a whole, was that the narrow set of applications that were appearing over and over again in their CS classes, build a poker bot, let's do a database design, and so on, were holding them back and giving them, they were lacking opportunities to apply computation to other fields that resonated more closely with them. And that was stymieing incredible talent and creativity. And also, it was holding back their appreciation for algorithms and their fluency of fundamental computer science. So over time, I leaned more and more into what so-called applied courses could offer people for making those fundamental abstractions real. Along the way, it hit me that Python wasn't just an ancillary player in how my students were making new computational revelations, connecting their neurons in interesting ways. The very syntax, the very look of Python, the fundamental zens underlying why it works the way we all know it works, they were also important. That being pseudocode that compiles, as it's often said, was enabling the rapid motions between abstraction, application, back, abstraction, and being motivated by a problem. Still being motivated by a problem when you arrive at the solution is part of the key of understanding. So, if I'm going to say two things worth taking away in this talk, the first one I hope to show in a second is that working with music and making music with Python can just be absolutely magical. But second, that the abstract and the applied have so much to offer each other and can keep going over and over. So let's talk about music in Python for a bit. I think that's why a lot of us are here. Now, music, unfortunately, has only a small presence in the standard library, but Python's music ecosystem has always been incredibly rich. We got great communities, Librosa, Splitter, Pedalboard we heard about last year. Is Pedalboard Tristan here? Magenta, and so many other logoless projects that are just amazing. But what we call music really has several different components, and this is a simplification, but there are the parts of music that are about metadata, and music organization, dealing with your playlists, extracting lyrics, and so on. Very important. Then there's music as audio, or music as sound, and such as making beats or pieces or changing effects or analyzing. And so this domain down below talks about frequencies or milliseconds and uses files with extensions like WAV or MP3. But music also has another domain, and this is one I mostly work in, that is thinking of music as notes, like C#, or durations, like half notes, or scales, like the pentatonic scale. And this domain might represent music by scribbled marks on a page, or an array of keys pressed down on a MIDI piano keyboard, or represented in a file like music XML. So this second way of representing music is called the symbolic music representation. Now, music's audio and symbolic sides are super important. They're like thinking of words as things that are spoken. Audio side might be thinking of words like spoken or recorded in a microphone, versus the symbolic side might be words written on paper or in a text file. And I think most top devs work back and forth and move back and forth between the audio and the symbolic sides of music. There are actually a few projects, recent projects, especially in the new AI domains, that really try to work with music exclusively in the audio representation. But I kind of think it holds them back a bit. Like, imagine trying to work with speech in a system that just did not have the concept of a string or a character. I mean, it just would be so hard. So we go back over and over again to the symbolic domain, where tasks like search, query, harmonic analysis, and some kinds of composition are much more easily done. But unlike with text, where Python and basically every programming language out there comes with numerous built-in tools for working with it. You got regular expressions, you got the console, you got detecting spaces and white space and so on. Packages for symbolic music aren't generally included in programming environments. That means your system's pretty dumb. It does not know. How many people read music here? Okay, good number. That the next D, E, F, G is A, not H. Even if you're German, it's not H. And that this is just something fundamental that I think your system should know if you're going to work with music. Or that you can't put two half notes in a measure if you put 3, 4. Those of you who read music, your eyes like burning. It's like nails on a chalkboard seeing that there. It's just not possible. So when I started, there were no tools in Python or any other object-oriented language for working with scores. And so this led to the creation of Music 21. So what is it? Sometimes somebody else can describe what you created better than you can, and Carol Willing did that for me. Music 21 is a set of tools to answer questions about music quickly and simply, so you can create, analyze, and share music with just a few lines of code. And I want to thank Carol for being one of Music 21's best and longest serving advocates. So what kinds of things can you do with it? Here are some things I've done and some others have done. You can visualize how certain notes or intervals are used differently across different regions in China. You can look at how certain chord motions became more common in late 20th century popular music compared to the 50s. I might be the only one who wants to find hidden quotations in different pieces of medieval music. I have a startup that teaches students how to learn music theory, and it's all Music 21 on the back end. They're analyzing scores for automatically making singing music synthesis. You can identify pieces that have been commonly attributed to Bach, but that are likely not by Bach. And one of my favorite things, you can check to see if songs in minor keys use more sad lyrics. Turns out they don't. So let me just give a quick, if I were bolder or younger, I would do this as a live demo, but I recorded this a little bit last night, how it would work. If you imported Music 21, just pollute your namespace for a second and put it all in. We're going to create the note A and A4, and we can see it. This is a note you tune an orchestra to. It has a frequency of 440, and its duration is a quarter note. That's just our default in Music 21. We can take it up a little bit, up a minor second, and see that it becomes a B flat, but that the original note is unchanged. Now we'll create a stream. The stream is a fundamental container in Music 21. That's why we put it in the logo. And we can put into it any musical object. So we're going to put some harmonies into it. These are some harmonies: A minor, F sus chord, C6. These are just standard things you might use in pop music. And we'll create a chord symbol out of each of them. We're going to say that we're going to write the chord symbol out as pitches rather than as a chord, rather than just words at the top. We append each one of them to the stream, and now we can see it. And if we show it as a MIDI file, we can hear it. Now, that's just a really quick one. The octaves are a little bit wrong and everything, but you can get higher quality if you want to do other things. Okay, so for our next demo, we're going to need the copy and the random functions. I'm just going to quickly make something called multi-show, which just shows it as notation and shows it as something we can hear at the same time, just to save some time. Okay. Let's create another stream. We'll call it a part, which is a specialized stream that knows it's going to have measures in it. And we'll create 16 notes, and we'll just take those 4 harmonies. The 4 chord symbols is how you extract them out. And we'll just go through them: 0, 1, 2, 3, 0, 1, 2, 3, so on. We'll take one random note, one random pitch from each of those chords, make a copy of it, and we'll just take it up. We'll take it up here, octave 5, and put it into the new part. Great, and so now we'll multi-show that. And there we go. We've just taken some random notes out of the parts. Okay, let's create a second stream. We're going to call it harp, and then we're going to listen for a second and realize that was really terrible. We got really bad with random numbers. So we're going to go back, run it again, and get that one's a lot better. So we're going to keep using that one in the demo. And now we're going to create a copy. We're going to go through each of the notes, maybe just the first 12 is what I did, yep. In this, and what we're going to do is we're going to take each of those notes, dam, ba, ba. We're going to instead make it go yadi da ba di da ba, or yada da ba di da da. So we'll take each note, cut it into 3 notes, each 1/3 the length of the previous one. And the first one will just be the same. The second one we'll do is we'll randomly go up one diatonic note up or down, one white key up or down, get rid of the accidental, and then the third note will be the same. And we'll append it to the stream we're calling harp. And we couldn't call the stream harp if we didn't put in a harp at the beginning. And, well, you can, but that'd be dumb. Okay, so you get something like this. Okay, do not enter that into any composition competitions. That's not going to win, but it gives a little seed for some of the generative things that you can do with Music 21 in just a few minutes. Music 21 is certainly not my own work alone. Here I've put all the contributors who have put 100 commits as a cutoff. 2 of them are here today, Chris Ariza and Jacob Walls, who introduced, and I'm super happy. And this has also been done through support from the Seaver Institute from MIT and the NEH and some others. Okay, so now for the other big topic. How can computational music theory and analysis enhance fundamental computation and computer science skills? The examples I'm using come from a class I taught in various forms called Computational Music Theory and Analysis. It's available free, all the lectures on MIT's OpenCourseWare. There's QR code there, but you'll have no trouble finding it Googling. There's not that many courses like this. So it's very simple things, obviously. Iteration hierarchies. An early assignment asks students to use tools to label a particular excerpt, how strong the beats are, in a single piece. It's much, much more tedious than doing it by hand. But of course, they quickly learn for loops, and that with a very few for loops, the same analysis can be done for every part of every piece by Bach. Different kinds of searching. Musical scores also lend themselves to different ways of recursively walking through or searching the score. Looking at music the way an individual player would, looking at all of the notes of his part first, before moving on to the notes of the next part, next player, lends itself to depth-first searching, or DFS. But breadth-first search makes it easier to find all the simultaneous notes. This walks through music how we hear it. One of the very important skills the students learn in the class is how to determine which strategy is best for which case. Identity, equality, and equivalence are three often confused terms from programming and computer science. Identity is Python's is operator. Where are we in memory? But the other two, underscore EQ and equivalence, these can be hard to figure out what you should be doing. When should we consider notes equivalent, and when should they compare as double equal? Like these G sharps. Are they equal or are they equivalent under some operation? Having a grasp on this fundamental abstraction ends up helping with understanding more advanced ideas that the students encounter later, like dimensionality reduction, which is a form of equivalence, or even concepts on the cutting edge of research, such as sparse autoencoding and AI interpretability. Scales and random walks within scales are useful for explaining the abstractions of graph theory and graph representations. The melodic minor scales, one famous one, Indian raga, are actually probably the most interesting ones to represent this way. Computational music classes help students understand the differences between ontologies, or ISA relationships, and meronymies, or HAZA relationships. Take an unambiguous one. A guitar is a plucked instrument. It is a string instrument, which is the equivalent of being a subclass, how you might do with shape and rectangle and all those things, versus a guitar has a neck and has a soundboard, equivalent to having an attribute. But music introduces so many ambiguous relationships as well. Is a chord a note with multiple pitches? Or does a chord have multiple notes? Or conversely, is a note a special kind of chord that only has one pitch? You could even go, is a rest a kind of chord with 0 pitches? Or is it neither? Or is it both? I have never seen a student argue about what's the proper way of representing the subclass of square from rectangle. But boy, this kind of thing seems very important to fundamental to how we represent music and maybe how we think of it in our head, and leads to really great discussions. Computational music theory also makes clear the problems of data representation. Here are some people whose music is included in many standard music history textbooks. Look at them for a second, you might know some of them. And here's the people whose music is available for doing computational analysis on large quantities of. Every modern CS class worth its weight talks today about bias and skewed data. I hope yours do, if you teach them, and how they lead to skewed results. But here, the problem of lack of representation in data is really made tangible and often inspires justified outrage. So I want to move on, but I just want to share a quick 30-second video, get some water, of a handful of the many student projects that have combined interesting Python code, music analysis, and also fundamental CS thinking.
You recommend classical music or folk music?
Yeah.
A two-octave scale alone has 186 quintillion possibilities. And we need to reduce this to 1. So the best one is 315, and then 215 and 415 are tied.
So I'm moving toward wrapping up, but I want to talk about for a bit how we can take what we're doing here, applied things. How can we move beyond music? What are the transferable and reusable patterns to use in other fields? So after developing this course, I was invited to create a digital humanities lab, which employed about 20 to 40 undergraduate programmers at any time. Most of them were in the first years, even the first semester, working at the lab at the same time that they were taking their first classes in computer science. And this helped them put the practical with the theoretical. The lab worked on projects such as analyzing the gender roles that appeared in a corpus of over 4,000 novels that they assembled, or studying how networks of influence and communication between tobacco researchers and tobacco producers were created in order to hide the dangers of smoking. By the way, in this lab, one of the things that learned how to do myself was how to get results from taking a very large task and cutting it up into a bunch of really small tasks to assign to a great group of clever but very inexperienced programmers. And I really did not think at the time that that was going to be at all a marketable skill, but things do change. There were other lessons that we learned. And one of the things that made Music 21 get adopted and help a ton with student learning was Arisa's insistence that, like the standard library of old, our package should also be batteries included, meaning that it should come with thousands of pieces already installed and ready to be analyzed and transformed right out of the box. Give people something to play with right when they pip install. And we did this with the Gender Novels project as well. We made sure that me and my staff had assembled a handful of novels and tools already so that students could get bit by the bug of analyzing corpus on day one. Another recurring pattern for applied projects that seems to work well is what I call the code and then unlock paradigm. So the students will start an assignment like model a chord or create a stream, or later on something like let's classify musical keys. And they'll start just with most things locked, maybe just a standard library or just a couple modules, and they have to create their own from that. But the important part is the unlock component. When they finish creating their chords or musical key classifiers, then we symbolically unlock the state-of-the-art tool and we look through the code that it uses so that learners can see what edge cases they weren't asked to cover or didn't cover, or what efficiencies they could gain and learn from that. If you're looking to apply these skills to your own learning, congrats. That's how I did it, and I know it'll work for you. I think it's important first to know what your own non-computational hobbies and interests are. It really doesn't matter, just as long as you're passionate about them. If it's counting possum babies, if it's collecting daisies or anything, do that. Then identify some skills that you would like to learn, specific ones in programming or computer science. Then you can try to figure out how they connect together, or you can use the great and welcoming Python communities online and here to help identify ways of connecting the two. If you just say, I want to learn how to program, people are busy. But if you say, I'm really having trouble understanding the divide and conquer algorithm, and I have all this possum scat I want to analyze, is there any way that I can do that? I guarantee you, people will make time for you, because the kind of curious mind will not be able to drop it until they've figured out themselves how to apply this. And the people will be willing to work with you. So I'm about out of time, and I'm just going to leave you with that note. Have the courage to embrace applications, knowing that they will reinforce abstract skills and notions, and let the streams of nourishing knowledge flow in all directions. Thank you very much, and mahalo.
Thanks so much, Mike. We have time for questions. Please use the center mics.
Hello.
Hello.
Outstanding talk. Thank you very much. I'm also a classical musician from the UK, and you keep talking about quarter notes and half notes and things, whereas I have crotchets and
Quavers
minims. Yes, exactly. And the thought struck me that what you're doing is writing about music in code from a certain cultural perspective. And I would use crotchets and quavers, and you'd be looking at me complaining like I'm doing to you. Do you, first of all, cover that? But also, perhaps, could you talk a little bit about how, because music represents a culture and a background and the people who've made it. Could you perhaps talk a little bit about how you encompass that or bring that into Music 21? I'd be fascinated to hear.
Absolutely. Thank you so much for that question. I think a lot of it goes to who is, just as I said, who is represented in our representations, who's represented in the corpora that we encode, who is represented in how we describe notes and things. And yes, I will admit that it comes a lot from US American classical knowledge. We try very much to make sure that there are different flavors of jazz chords that are available, that you can, I don't have a live terminal up, it's probably good because I would just get distracted, but you can type that note, you can type n.German and you can get it in German, n.French, and and I would love to have more things come in. I think one of the lessons that I have learned is that early on, we tried to put in everything into Music 21. I mean, there is things where you can understand how the variability of rhythms relates to the variability of speech patterns in various languages. And over time, I came to thinking that the most valuable thing is to create programs things that can accept plugins. So you can change the defaults so that quaver and crotchet and hemi-demi semi-quaver and all these wonderful, beautiful British terms can be used just as equally. There are also some places where we have real cultural assumptions built into Music 21, and there was always these trade-offs. Early on, there were so many cultural assumptions. I tried to make sure were nowhere in the code so that we could represent the only things that I knew, that we could represent Indian raga equally well to circular scales. And over time, I did have to come to the decision that, I'm going to special case the major and minor scale so that they work about 50 times faster than the super flexible format. So these trade-offs will always happen. I think we need to keep thinking about them and keep talking about them. So thank you. You weren't a plant, but what a great question. Thank you.
Hi. Can you synthesize like new sounds in Music 21, or is that like an add-on or something?
So if you're talking about new sounds, I mean, everything that we heard was a sound that has never been heard before. But if you're thinking about like, what are new timbres, what are... I love those things. If we go back to any one of the many packages listed, let me see where I can find the slide. Here under the audio synthesis and analysis domain will work better for that. There is a software package called PyAmpack, which is specifically for creating sounds and analyzing sounds connected with Music 21. So that's probably the best way to do it. But just as what was it they always say? You can always upgrade a toaster to to run a web server on it, but you can generate sounds with Music 21. It was probably a new things, but it's probably not the best use of it. So thank you for a great question.
One quick follow-up question: Can you pipe the music data from Music 21?
Oh, yeah.
Something like a DAW, like
definitely.
FL Studio or something. Okay.
Definitely.
Thank you.
Yep. Other questions? Any other first timers with questions? Anything? Yeah. Thank you.
Hey,
Brief. That was
sorry. I don't know. I know very little about music. I can barely listen to music. Can Music 21 be a good tool for someone like me who knows how to do code to learn how to do music, or is it just more the other way around?
Yes, great question. I have certain tutorials in this class. I think the first 4 or 5 would be really good to go through for that. I don't know if somebody else has made. I think somebody had made one, but it might be quite old. A tutorial on how to learn music from Music 21 to do it. But it was great. The company Artusi, that startup I founded, uses it, and you can write to me, and I'll give you some of the code that we can see, and we can go through that.
Incredibly, we're out of time. Please join me in giving another round of applause.
Thank you.